Okay, we're going to look at some example problems converting between mass, moles, and particles. In the first problem, we have 4 moles of C2H6, and we want to know how many molecules that will be. Avogadro's number is 6.02 times 10 to the 23rd molecules in 1 mole. So Avogadro's number relates the number of molecules to the number of moles. And what we actually have, we do not know the number of molecules, but we know that we have 4 moles. So basically, we have 4 times, or we should have 4 times the number of particles. So instead of 1 mole, we have 4 moles. So I've set up a proportion here. And all you really have to do to solve it is take 4 times 6.02 times 10 to the 23rd. I'm just cross multiplying. And when I do that, I find that I have 2.408 times 10 to the 24th molecules. Now I do need to have the right number of significant figures. So rounding that to 2 sig figs, 2.4 times 10 to the 24th molecules. In this problem, we're going to look at a second example problem. Here, we're given the number of moles of oxygen, and we want to know how many grams there are. The relationship between mass and moles is known as the molar mass, and as we've already discovered, you find the molar mass from the relative masses on the periodic table. Oxygen is a diatomic molecule, so its molar mass, there are 2 atoms of oxygen in every mole of oxygen. So we're going to find its molar mass by taking 15.9994 times 2. So there are basically 32 grams of O2 in every 1 mole of O2. And I'm going to use that relationship between mass and moles to determine the mass of 15.4 moles instead of 1 mole. So I set up my proportion, 32 grams of oxygen in every 1 mole of oxygen. But I don't have 1 mole of oxygen, I actually have 15.4 moles of oxygen. And I want to know what that mass is going to be. I'll have mass on the top because I have mass on the top on the other side of the proportion. So I cross multiply, I'll take 32 times 15.4. What this is saying, I basically have 15.4 times the mass of oxygen that I would have if I only had 1 mole. When I did that, I got that there were 492.8 grams of oxygen in every 15.2 moles, or 15.4 moles of oxygen. But I need to get that in sig figs. My original number, right here, had 3 significant figures, so my final answer needs to have 3 significant figures. The 2 is going to round up because there's an 8 behind it, so I will have 493 grams of oxygen as my final answer in every 15.4 moles of oxygen. So there are 2 example problems.